All right, I got several emails about number 3 yesterday, so I will go over number 3, elasticity of demand, in that Google Doc today, okay? All right, so far I went over, no one emailed me about number 1 or 2 yet. 3, I'm doing that right now. 4, I went over 4, went over 5, and I also went over number 7. I'm going to wait today, and probably today's the last day that I will take your questions, since tomorrow morning at 9 o'clock, you guys are going to start on your exam. So try to please email me before, because my son comes home at 5 o'clock, and when he's in the house, I can't really record anything or do much work. So if you can please try to send me your questions by like 1 or 2 o'clock today, that will be great. If not, I'll try to wake up early tomorrow. All right, but tomorrow morning I will send you your exams, and I will have something posted for 4.4, properties of definite integrals. This one is probably going to be the most straightforward, number 8. And I will even maybe go over this one later today, because I'm kind of giving number 8 on the exam as like a daily problem for section 4.4. But if you need to see anything, you just let me know. Your actual exam is going to be very similar to this. I'm trying to make it very easy for everybody. As long as you study, as long as you review this, you will be okay. And Cecilia also asked me a great question. Are we allowed to use notes on exam 3 or final exam? And the answer is yes. If you feel like you need to use your notes, do that, okay? Don't feel like, it needs to be completely, closed book, closed. No, use the resources that you have available. You worked on those notes, you worked on those review problems. So if you want to use them, feel free to use them, okay? All right, number 3. So number 3, we did this on, can't remember which week, about 2 weeks ago, elasticity of demand, and we kept the notes pretty short. Now, I will also list these things, like this is from section 3.7, so that in case you're taking your exam, because you guys learned a lot of material in the last couple of weeks, 3.7 notes can be found under week 13. That's April 13th through April 19th. And the note was pretty simple. We talked about the equation, elasticity of demand equation, which was, now take a look, we're going to need this one very soon for number 1. Negative x times derivative of x divided by the d of x. And d of x was the demand function, right? So you're going to find the elasticity function using that equation first. And then, remember, you guys took a short quiz on Canvas for me after learning this lesson. When that elasticity comes out to be less than 1, we say it is inelastic. And what that means is that if you raise the price a little bit, well, then it's going to increase the total revenue, okay? If the elasticity comes out greater than 1, we say it is elastic, and small rise in price will result in actually decrease in total revenue. Now, what if it's equal to 1? Well, then the total revenue is already maximized, and that case is called unit elasticity. So number 3 on that Google Doc, number A, B, C, D, I think part A through D can be solved just based on that information that we just kind of went over. So let's go. And feel free to come back to this note as much as you can, because these terms are kind of, well, if you're taking econ, you may see them more. All right, so let's go to the problem. And what I did was, you can copy that Google Doc, I believe, and then just add more spaces if you want, and print it out if you want to, or just write it on a separate sheet of paper. That's what I did. So that I can do all A through G on this. So suppose you have been hired as an economic consultant concerning the world's demand for oil. The demand function is Q equals D of x equals 35,000 plus 150x minus 4x squared for x is in between 0 to 180 inclusive. Okay, what does X stand for? Let's read. Where Q is measured in millions of barrels of oil per day at price of X dollars per barrel. Okay, so this demand function is a function of the price of X dollars per barrel, and this is gonna give us the demand in measured in millions of barrels of oil per day. Okay, so first, let's find elasticity. I'm doing A first. Remember, elasticity function is simply e of x equals negative x times d prime of x divided by d of x. So you will need that formula, right? So I need to find d prime of x. Okay? So if the function is 35,000 plus 150x minus 4x squared, let's take the derivative of that. 35,000 is gone. 150x will give me 150. And then minus 4x squared, that will turn into minus 8x. So that's the derivative. So I'm going to go ahead and plug this into this elasticity function. This equals negative x times that d prime of x that we just found divided by the original function d of x, which was 35,000 plus 150x minus 4x squared, right? And this is fine. This is correct. What I did was, because this one was a textbook problem, I think what they did, they just simplified it. We can distribute this and get 8x squared minus 150x. And when I distribute it, I just kind of move the 8x squared to the front. And then 35,000 plus 150x minus 4x squared. And that's okay. This is fine. But if you, what the book solution did was they just simplified this a little bit further. They divided every term by 2 because all these are even terms or even number coefficients. So we can just simplify this as 4x squared minus 75x over, oh dear, what's half of 35,000? 17. Is that it? I guess. Probably 75x minus 2x squared. Now, I kind of typed these answer keys in at like midnight one day. So, and a couple of mistakes were found and they've been fixed. So I'm going to go in and double check if this is matching the answer key, the answer that I provided. So, let's see. Oh, where is it? Oh, it's down here. So elasticity function in the answer key is 4x squared minus 75x, 75,000, 17,500 plus 75x minus 2x squared. And it looks like it, right? So that's how you find it. That's how you find part 8. That's how you find the elasticity function. Okay, sorry. So I came back. Now, we're going to use this now. We're going to use this now to answer some questions. No, that wasn't it, right? I had extra zero stuck in here. Whoopsies. I don't need that extra zero. Now, that's good. Now, that is good now. Okay. After finding the elasticity, we're going to be able to use this function to find the answers for B, C, and D. Okay? And based on the number that you get, remember, if it's greater than 1 or less than 1 or equal to 1, that's how we decide if it's elastic or inelastic or at a unit elasticity. I think that was a word. So you're going to have to just plug in now, B. Let's plug in, find the elasticity at a price of $45 per barrel, stating whether demand is elastic or inelastic at that price. All right, so let's find E of 45. That's going to be 4 times 45 squared minus 75 times 45 all over 17,500 plus 75 times 45 minus 2 times 45 squared. All right, you have a calculator with you? I do. Go ahead and type this into your calculator and see if you and I get the same exact thing, okay? I'm typing this in. Minus 2 times 45 squared. When I typed this in, I got 189 over 673. Let me see. Is this matching the key that I provided? Yes, 189 and 600 over 673. Now, I typed in a fraction, but in decimal, if you just divide the numerator by the denominator. The decimal answer is 0.28. And that number, notice that 0.28, well, that fraction, because the numerator is smaller than the denominator, this number is smaller than 1, right? And remember, when the elasticity comes out to be smaller than 1, when it comes out to be smaller than 1, we call that it is inelastic, which means if you if you increase the price a little bit, it's going to increase the total revenue. So that's why, because that number is less than 1, you just simply have to tell them, oh, it is inelastic. All right, so let's go ahead and say inelastic for that one. Sorry, I just have to keep jumping because I want to make sure that the key that I typed up last week is all correct. And so far they are. So say this is inelastic, and it's because it is smaller than 1. Now let's try the same thing for C and D. That part's going to be a little easy. Just plug in 60 this time. So that will be 4 times 60 squared minus 75 times 60 all over 17,500 plus 75 times 40, no, not 45, 60 minus 2 times 60 squared. So on the exam, make sure you give me both parts, okay? Give me the answer, like what is the number that you got, and then decide based on that number, is it elastic or inelastic, okay? I am typing this into my little calculator on my hand. All right, I got this, 99 over 148. Again, this number is smaller than 1, right? And 1 is a number that you're comparing to. So if it's smaller than 1, you're going to tell them this is, hey, inelastic. Because 99 over 148 is smaller than 1. Okay? And same thing. Hopefully, D is a little different. Now, D, right now it's already at what, $75 per barrel. So if they increase the price a little bit, will it increase the total revenue too? We'll see. E of 75, plug in 75, equals 4 times 75 squared minus 75 times 75 all over 17,500 plus 75 times 75 minus 2 times 75 squared. I don't think you needed help with this part. I think it was probably part E or something else. But, you know, why not? As I'm going over it, I want to do the whole thing. So you may skip forward if you already got this part. Minus 2 times 75 squared. What did you get? I got 20. I thought at least 1 would come out to be elastic. Oh, you know what I did? I gotta slow down when I do my math problems. When I typed in this, I added an extra 0 for 17,500. So if I delete that, yes. You should get 27 over 19. And notice this 27 over 19 is definitely greater than 1, right? What do you say then? This is elastic. So if it's elastic, if the demand is elastic, then what we get to say, if they increase the price a little bit, the total revenue will actually go down. It will decrease a little bit. So, all right. Maybe it's already too expensive. All right, at what price is the revenue a maximum? Now, this one is probably what everybody's emailing me about. Now, remember, revenue is maximized when elasticity is equal to what number? 1, right? So what we're going to do is we're going to set that elasticity function equal to 1 and solve for x, okay? All right, part E, let me use a purple pen, E. Find the x value that will make E of x equal 1. Now, what was the word that we used? Unit elasticity. Remember, when E of x is 1, the total revenue is maximized. Whoopsie, don't go. And now notice that I am doing very good at exams. I got 2 left. So, I promise Corey and I think one more person. Corey and I think Saeed. I'll get these done like today, okay? All right, and going back, where am I? Plug in 1 into the left side, and put your elasticity function on the right side. And we are solving this for x. Okay, we're solving this for x. Solve this for x. Well, let's go ahead and first multiply both sides by that denominator. So let me multiply both sides by 17,500 plus 75x minus 2x squared. 17,500 plus 75x minus 2x squared. So that this cancels out. I'll get 17,500 plus 75x minus 2x squared equals 44x squared minus 75x. Okay, hold on one second, guys. What I'm going to do is I'm going to minimize A, B, and C and D a little bit so that I can try to squeeze in my work for E on the same page. Maybe that's not going to be possible. I don't think that's going to be possible because when you solve these real world problems, guys, how likely is it that they're going to actually factor into something nice, right? We may have to use a quadratic formula. So let me just move part E over down here. And I'll just keep these guys up here. Okay, so we're solving this quadratic equation. So let me move everything to the left side. If I subtract 4x, I just want to make my work very clear so that you see what I'm doing. If I subtract 4x, I will get negative 6x squared. And then I will add 75x2. Add 75x2. Then that's going to give me 150x. And then the constant is 17,500. And that equals 0. Now we're solving a quadratic equation. And I don't think it will factor nicely. So I'm not even going to try to factor. I'm going to go ahead and either use, what's your method? You like quadratic formula or completing the square? I mean, I personally like completing the square, but with us having a leading coefficient that is greater than, that is negative 6, it may be easier to just go with quadratic square. Let me check something. Can I go ahead and divide everything by negative 6? I'm just going to see if I can factor out that leading coefficient. Is 150 divided by, can be divided by negative 6? Yes, that one does. What about 17,500? Can it be divided by negative 6? Ah, no, not that one. Maybe when I make up your exam 3 problems tonight, I'll make sure to give you something that is maybe at least factorable. Well, I don't know. I'll try. But, okay, so it's not factorable. So I'll just do a quadratic formula here. Why not? Quadratic formula. What's A? A is negative 6. B is 150. And C is 17,500. So X is equal to negative B plus or minus square root of B squared minus 4AC, all divided by 2A. All right, so that's going to be what? Negative 150 plus or minus 150 squared minus 4 times negative 6 times 17,500, all divided by 2 times negative 6. All right, let me figure out the discriminant first to see if you're going to even have a solution. So what I'm doing is I'm typing in 150 squared minus 4 times negative 6 times 17,500. So what's inside the square root? Guys, I got this. 442500 divided by negative 12, right? Okay, now, just out of curiosity, do you think that is a perfect square? Of course it's not. It wasn't. So, you know what? I got 2 answers then. X is either negative 150 plus square root of 442,500 divided by negative 12. Or X is equal to negative 150 minus square root of 442,500 divided by negative 12. They only differ by what? The sign in the middle, right? Well, get me the decimal for both of them. Let's get the decimal for both of them. Now, remember what X stands for. X stands for the dollar amount, right? How much is the oil price, oil per day, what was this? X dollars per barrel. So we're talking about price here. So we should not get a negative answer. So if one of them comes out to be negative, we're just going to throw it out, okay? So let's go ahead and solve it. And we shouldn't get something crazy big. Like, because you see how the numbers they were giving us was like 45, 60, and 75-ish. So we should get something around that area. And we should get something, actually, that is greater than 60, but less than 75. You agree? Because when it was 60, it was inelastic. And when it was 70, it was elastic. So something happened in between those two numbers. Oopsies. And guys, if you ever feel like you need to make up anything from this crazy semester, feel free to reach out. You're not going to upset me if you say that, oh, I need an extension or anything like that. Oh, negative. We'll work something out together. Oh, take a look. The first one I got is negative $42 and negative $42.93. This answer is negative. No good. Because we're talking about oil price. Nobody is going to give us money for using oil. So we're looking for a positive answer. So I'm thinking the next one will be. Go ahead and type that in. And get me the decimal, okay? I changed that to that. Okay, so I got $67.93. And this is positive. This must be it. 67 cents and 93 cents. $67.93. Now, let me see if this matches the answer key that I typed up one midnight. $67.93 per barrel. Yes, that's it. So that's how you get the answer for E. I know it was kind of the fact that we had to bring out quadratic formula, but that's something in your toolbox, right? You do know how to do that. Alrighty, let's go ahead and figure out F and G, and that will be it for number 3. Not necessarily difficult, but you see how it is a little bit longer because just you have to do a lot of work, right? Or let's do F. What quantity of oil will be sold at the price that maximizes the revenue? Now, F cannot be sold without, F cannot be solved without figuring out the answer for E, right? Now, what we're going to do is we're going to simply plug in the answer that we just got, $67.93, into the, which function then? What quantity of oil? So the demand function. We're going to just plug it into the demand function. So remember the demand function was 35,000, right? The one up top that I gave you in the beginning. And then you're just going to plug in 67.93 in there. No, I'll do it down there. Okay, so we're doing part F now. F. Plug in X equals 67.93 into D of X, the demand function. Okay, so D of 67.93. And don't plug this into the elasticity function. Guess what you will get if you plug this into the elasticity function? You get 0. I'm sorry, you get 1. That's how we got that number, right? Or you may get something very close to 1 because we just rounded our final answer there, right? So it'll be very close to 1. But to plug it into the demand function, and which was 35,000 plus 150 times X minus 2 times that number squared, right? So go ahead and type this in. 35,000 plus 150 times 67.93 minus 2 times 67.93 squared. And that comes out to be, I'm getting worried. This doesn't look like the answer that I got. Now, is that even the right elasticity function, the demand function? Oh, jumping from page to another is just so difficult, guys. Give me 1 second. 35,000. Oh, no. I plugged in. You see, I wrote the wrong function. The last term should be minus 4x squared, not minus 2x squared. Okay, I'll fix that. Minus 4x squared. Okay. So just like a silly mistake like that may happen. So that's why it's very important that you show me every step of your work, because like if you just did what I did, like you accidentally just put in 2 instead of 4 on your exam, I don't want to take off more than 1 point, right? But if you don't show me that and just write down the wrong answer, then that's not going to be good. So make sure you show me everything that you're typing into your calculator, and the answer comes out to be 26,731. Now, what was the unit though? We're talking about how much is sold. So was it pounds? What was the unit? Millions of barrels. Okay, millions of barrels. Let's write that down. Millions of barrel. I think that's how I spell it. Okay. And is that matching what I typed up? Let's see. Yes. Oh, they rounded up. They rounded up. Well, we also did, didn't we? So so far it's looking all great. And then we're left to what? Last one. Oh, I didn't round that up. Let me go ahead and round that up. 732. Okay. Let's do the very last one, which is asking you for G. In August 2017, a barrel of crude oil was selling for about $48. Huh. $48. Now look, $48 is in between 45 and 60. And looking at the, I shouldn't really estimate, but I'm expecting the elasticity to come out to be inelastic. I think the elasticity will be smaller than 1, because both of those, A and B and C, when we plugged in 45 and 60, we got a number smaller than 1. So if it is inelastic, what will a small increase in price cause the total revenue to do? Will it make it increase or decrease? If it is inelastic, it's gonna make the price, the increase in price will increase the total revenue. So let's take a look. What I will ask you to do though for G, do plug in 48 into the elasticity function, and show me that number, and then make a conclusion. Okay, so let's do that for the last one, G. Find E of 48. Okay, so E of 48 equals gosh, I forgot the function. 4 times 48 squared minus 75 times 48 divided by 17,500 plus 75 times 48 minus 2 times 48 squared. All right, time for you to use your calculator. Okay, that comes out to be, they gave me a decimal, 0.3541. Why couldn't they give me a fraction this time? I wonder, but that's okay. Assuming that I typed in everything right. And when you type this in your scientific calculator and you get I typed in 45 on the numerator. That's what happened. Change it to 48. It's still smaller than 0.34. That's what I got. Now notice, because E of x, E of 48, is equal to 0.34, which is less than 1. Demand, I should say, elasticity at $48 is what? Inelastic. So small increase in price will, what's the word? Increase the total revenue. So that's the conclusion. Based on the elasticity, the number, we know that that is smaller than 1, so they can increase the price a little bit and still increase the total revenue. So that is it for number 3. It was multiple parts. That's why it took a little bit longer time. But hopefully this was helpful. I will wait for your email. Please send me something before 5 o'clock today so that I can provide that extra resource for you, okay? But I know you're studying this week, today, for your exam at 9 o'clock.